Go.
12(2). Okay, is called evaluating limits algebraically.
Yay. Dang it.
Okay, so, oh, let's make this bigger so you guys can see it. Finding limits algebraically is, I think, kind of instinctive. Okay, so first I'm going to give you the notation for finding a limit algebraically, and then we'll just do some examples. Okay, so if you're asked to find a limit as x approaches c of some function, usually all you have to do is simply plug, whoops, my c forgot, plug the c into the function. And that will be your answer. Okay? Yeah. So, usually if we have a nice function like 4x squared plus 3, and we're asked to find the limit as x approaches 2, all you would have to do is plug 2 into the x value. Okay, so you'd have 4 times 2 squared plus 3. So let's see, 2 squared is 4, and 4 times 4, 16. So 16 plus 3 would be 19. Okay, so that would be the actual value of the limit at 2.
So 19's the answer.
Yep.
Bam.
Bam. Okay.
Right?
Not entirely.
Uh-uh.
So let's say that there's the scenario kind of like the warm-up today. Okay, so this works when functions are continuous. Okay, now if I say continuous, do you understand what that means for a function?
It goes forever.
No.
Dang it.
Not necessarily. There's no holes and there's no breaks or gaps. Okay, so the easiest way to tell you that a function is continuous is if you can draw it without ever lifting your pencil. Okay, so if you end up with a function that is not continuous, that can cause problems. Let me show you an example. Okay, are you guys ready?
Wait for it.
Okay, what should we do first? Yeah, well, no, we're not going to graph it yet. In fact, we're only doing this algebraically. We're not going to do any graphing. Okay, so the first thing we're going to do is we're going to plug the 2 into it. So we have 2 squared plus 2 minus 6 over 2 minus 2. And as Hunter has said, we end up with what? 0 divided by 0. Okay, so you cannot divide by 0. So this should be like a big, oh gosh, what do I do?
That means that the limit, there's a hole there.
Yes, it does mean that there is a hole there. Okay, so anytime that you get a 0 over 0, that does imply a hole. So there is a limit. We just have to figure it out. So what we're going to do is we are going to go back and we are going to factor the original expression. Okay, so if I go back to the original, what does x squared plus x minus 6 factor into? What two numbers multiply to negative 6 and add positive 1? So x plus 3 and x, whoops, minus 2. Okay, so what do you notice?
Wait, why did we get those? Oh, okay.
Factoring.
Just the top for now.
Yeah, because the bottom is, you would factor the bottom if it could be factored. Okay, so you have an x minus 2 on the top of the bottom, so you're left with x plus 3. So now what we're going to do is we're going to take x plus 3 and now plug our 2 into the function. Okay, so what is 2 plus 3? 5. So 5 is the value of the limit. Okay, so you would be able to see that graphically if you plugged it into the calculator. You could see it looks like it's going to 5.
So good. whole, you have to factor, then you
Exactly.
But you only factor the top?
You factor all of it if you can. So if you can factor the bottom. Yeah, it was a linear
So does that mean
quantity.
the hole's at 5? Is that what
The whole is at x equals 2 with a y value of 5. Yes. It would be at 2, 5. Yep. Okay, so do we understand the 0 over 0 scenario?
Got it. All right.
Okay. Let's try another one.
Another of the same one?
Another one. Okay. What do I do for this equation? What is always my first step if I'm doing this algebraically? Plug in the numbers. So I'm going to start by plugging 5 into my x's. So I have 5 squared plus 3 times 5 minus 1, and 5 minus 5 on the bottom. So on the top I have 25 plus 15 is 40, and 40 minus 1 is 39. So in this scenario, we get 39 divided by 0. Okay, so again, there's some kind of thing happening with the graph. Okay, so this time we have a number being divided by 0, and what happens in that case is that's going to be a vertical asymptote. Okay, so like the warm-up today, the graph splits apart. Okay, so what is a limit at that kind of scenario when it splits apart? It does not exist. Exactly. Okay. So anytime you get a number divided by 0, that is a does not exist. Okay. We good with that? D and E, yep. Okay. Now the next part of this is going to be looking at limits that go to infinity. Okay, and so before we look at limits of going into infinity, we have to go back and kind of remember how horizontal asymptotes come into play. Okay, so this will be a little bit of maybe review, maybe not. See if you guys remember horizontal asymptotes. Okay, so there's 3 ways that horizontal asymptotes can exist. Okay, I'm going to do this by example. The first case is if you have, let's say, x or 2x squared over x plus 1. Okay, so when you are evaluating or looking for horizontal asymptotes, what you are looking for is the exponents, the biggest exponents on the top compared to the exponent on the bottom. So in this case, is the exponent bigger on the top or is it bigger on the bottom? On the top. Okay, so if the exponent is bigger on the top, bigger on top, you might have to say exponent in your notes, whatever helps you. Okay, then that is going to imply that there is a slant asymptote. Asymptote. We did it in Algebra 2. Well, we might have done it in here. Yeah. So I think we did it in Algebra 2 and we did it earlier when we were doing algebra.
So, what would they ask you? You said, what is...
Oh, I'll show you. I'll do examples of it. Okay. So second scenario is if we kind of have the opposite of this. Let's say you have x plus 1 over 3x squared minus 2. Okay. So this time my bigger exponent is bigger on the bottom. Anybody remember? Bigger on bottom what it is? It's always the same. Not 1. That's close.
Horizontal asymptote?
Horizontal asymptote at y equals 0. Okay, so anytime it's bigger on the bottom, horizontal asymptote is at 0. Third case. What's my third case? When they're the same. What? What? Oh my gosh.
Wow.
Yeah, I kept writing it and disappeared. You guys saw that, right? Let's try again. Okay, so let's say you had something like 3x squared minus 4x over 5x squared plus 2. Okay, so in this case, they're the same. Okay, so this is going to imply a horizontal asymptote at, can you remember this? No? Okay, I'll tell you, 3/5. Okay, where did I get 3/5 from? Yeah, the values that are in front of the x squareds. Okay, so see how there's 3x squareds and 5x squareds? That's what causes your horizontal asymptote to go up to that. That makes sense? A slanted, so like that. And I'll, no, absolutely not. And it doesn't matter because when we're doing limits, it will be, if you have a slant asymptote, it's either going to be going up to infinity or down to negative infinity. So I'll do an example of that. Okay, so here are your limit examples that go to infinity. What number am I on? Like number 4? Okay, so number 4. So let's say they ask for the limits as x approaches infinity of 2x squared plus 1 over x squared. Okay, so first of all, what do you notice that's different about this particular question versus the first 3 that I did?
Because it approaches infinity.
It approaches infinity. We don't have a finite value to plug into the equation. Okay, so this is where we start thinking about horizontal asymptotes. Okay, so in this scenario, do I have a horizontal asymptote? Okay, where is my horizontal asymptote? At y equals 2, and that's exactly what the limit is. Okay, so that means as the function goes further and further to the right, it's going to level out at 2 and get really infinitely close to 2. Okay, so that's it.
It's
Still a limit, yep. Mm-hmm.
But when it's not going to infinity, it's going like this.
Does not exist, yeah. But that would be like, if it goes like this, it'll say the limit as x approaches 3 or something. They'll give you some finite value where the function splits apart. And then you'll have a 0 over, or a number over 0 case when you plug the number in.
It's not.
Yeah, anytime you go to infinity, you're thinking about horizontal asymptotes. Well, yeah, it exists. Yeah, it always exists when it goes to infinity. I think. Unless the function just stopped at like 2, like a circle. You know what I mean? Yeah, that would be a trick question, right?
What is the horizontal asymptote?
my oval. Okay, so what about this scenario? As x approaches infinity of 2x squared over x plus 1. So which case is this? Bigger on top, so therefore I have a slant asymptote. Okay, so I know that this function is either going up to infinity, if I have a positive slant, or it is going down to negative infinity. Okay, so all I'm going to do is I'm going to actually graph this one and just look at it and see. Okay, so I'll pull up my Webbit. I wish you would quit asking.
It depends on how you look at it.
Well, as x approaches infinity, which means at the far right of that, where is it going? Okay, so here is our slant asymptote. So you can see that it's curved up, it has a positive slant. So if we're looking at the far right of that function, where is it going? What height is it trying to reach? Infinity. Okay, so kind of a note to self, anytime you have a slant asymptote, you're going to be going either to infinity or to negative infinity.
How can we look to the right side?
Oops, whoop. Because it says as x approaches positive infinity.
So we look at something in the positive zone.
Yep. So I'm looking, yeah. If it said as x approaches negative infinity,
It would be negative.
then it would be going down, yeah, to negative.
So do we really even have to graph it?
Yeah, you want to graph it. Because otherwise you don't know if it's a positive slant or a negative slant. Unless you know what that function looks like.
Why is infinity? What's the answer?
Because it was going up on the far right. As x approaches infinity, the far right of that graph, it is going up and up and up and up. So it's going up to infinity.
You would say equals 0 because it's just where it changes.
Right, yeah. You're kind of thinking of calculus, actually. Let's try this one. So they're going to kind of do some fancy stuff with these limit ones. Let's say you have the limit of 3 plus 2 over x squared. Okay, so if they give you a function that is in pieces like this, where you have an x term, or not an x term, I guess that's a constant term, and a second term, you can take the limit of each term and then add those limits together. Okay, so let's start with 3. What is the limit of 3? 3. It's always 3, right? Because it's a straight line. It's always at 3, period. So we have 3. And then for 2 over x squared, thinking horizontal asymptote, is that bigger on top, bigger on bottom, same? Bigger on bottom. So bigger on bottom says there's a horizontal asymptote at 0. So 3 plus 0 is 3. So that's where the limit would be going. Because 3 is just a horizontal line. It's approaching y. Limit is the y value. What is the height of the function? What? Because 2 over x squared is a case where it's bigger on the bottom. For your horizontal asymptotes, bigger on bottom always goes to 0. Yeah, that's it. Yeah, that's it. So the assignment's on page 754, and you have 2 through 46 evens. Okay, so this will be a 2-day assignment, and it'll be due Friday at the beginning of class. Oh, I want it from you.